Okay, so now what we're going to work on are what do the graphs look like? So we've done the unit circle from 0 to 360 or from 0 pi to 2 pi. And also the negatives. We've found out what all the trig functions are, all 6 of them: sine, cosine, tangent, cotangent, cosecant, and secant. So now we're going to look at what do their graphs look like. Because one of the important things is what does sine graph look like? What does cosine graph look like? Well, we've done the hard part. You notice in the top I filled in from 0 to 2 pi. And then on top I wrote in what the degrees are. Okay, so I literally just copied it from the tables and notes you've been submitting. Okay, so it's just once you've done the work once, you don't need to do it again. Okay, so now I'm just going to graph it to see what this guy looks like, to see what happens. So for sine, so right now I'm graphing sine. This is sine I'm graphing. Okay, so at 0, it's going to be 0, so I'm going to make a dot at 0, 0. Okay, at pi over 6, 30 degrees, it's 1/2, positive 1/2. Okay, pi over 4 is square root of 2 over 2. Well, to graph it, I'm going to change it. I'm going to approximate it. This is the only time you approximate it. Okay, so the square root of 2 over 2. So the square root of 2 is 1.414, continues on forever. Divide that by 2, you get a number that's about 0.71. So about 0.71, so it's more than 50%, it's more than 0.5. So it's probably right about there. Okay, and then the next one for pi over 3, it's 3 pi, or square root of 3 over 2. Well, the square root of 3 over 2, it's a little bit more. It's about 0.87, 0.87, so just a little bit more. Okay, and then at pi over 2, sine is 1. And then after that, it goes back. It goes back to 3 pi over 2, or sorry, square root of 3 over 2. And then it goes back down to square root of 2 over 2. And it goes back down to 1/2. And then for pi, it's 0. And then it does the same thing. Now we're dealing with the negatives, though. So 7 pi over 3, which is 7 pi over 6, which is the same as 210, is negative 1/2. And then 5 pi over 4, negative square root of 2 over 2. So that is the same as positive square root 2 over 2, just a negative number. So it's going to be about negative 0.7, and then negative 0.86, and then here we get down to negative 1, and then we come back up. And then we finish with 2 pi. Okay, so as you can see, this is what the graph of sine looks like. It looks like a wave. We call it the sine wave. Okay, so the question is, okay, well, what does it do afterwards? So we've got down back to 360. What happens at 360 plus 30? So 390, which is 13 pi over 6. What happens there? Well, 390 is really the same as 30 degrees. It has that reference angle, so it's going to repeat itself. So this is going to be 1/2, and it just repeats itself. So I'll use a different color to show. So the sine wave just repeats itself over and over and over. So what you're looking at in red from 0 to 2 pi is what we call one cycle, or one period. One cycle, or sometimes it's pronounced a period. Okay? That's one cycle of the sine curve. All right, so now the question is, what do the others look like? What does cosine look like? What does tangent, cotangent, cosecant, and secant look like? So what I'm going to have you do for your assignment is complete a table. Again, don't try to reinvent the wheel. You have a lot of these numbers here. These numbers here, you have from the unit circle and also from your tables that you've been creating. So fill in those tables and then sketch the curve. Sketch what it looks like. Some of them will be waves, some of them won't be waves. Okay, and you're not going to get the same values for some of them. Okay, so that's going to be your assignment. All right. So the domain and range, intercepts and asymptotes. So for the sine wave, the domain is the x value. So remember, domain is x. So really what they're asking you, is there anywhere on this x-axis forever and ever in each direction where sine will not exist? Nope, there always will be a sine. Sine will always exist. So if sine always exists, then domain is all real numbers, or you can say negative infinity to positive infinity. Either one's okay. Okay, range. Range is the y values. So where on the y-axis will sine never go? Well, so there is a top and a bottom to this guy. So sine will never be above 1 or below -1. There's no way for regular sine, just sine of x or sine of theta, there's no way for it to go above 1 or below -1. So we would say for the range, we would say from -1 to +1 inclusive, because it can be 1 or -1. Okay? Intercepts. Well, intercepts are where it crosses, first of all, the x-intercepts. Well, the x-intercepts are 0, pi, 2 pi, and it continues. It continues every pi. So the intercepts continue every pi starting with 0. Okay? So it's just going to be, so there's going to start at 0, and then they'll exist every pi. So 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, it'll always be there. Okay, asymptotes. Well, again, asymptotes kind of go with domain. If there are restrictions with the domain, there will be asymptotes. Well, we just said the domain is everywhere. Anywhere along this line, there could be an answer. Okay, there's never not going to be a sign of a value of an angle. So for this guy, there's going to be no vertical asymptotes. But there are horizontal. Horizontal go with the range. Horizontal, it can't go above 1, so we're going to have y equals -1 and y equals 1. Okay, because it's never going to go above 1 or below -1.